Hello. If you want to master PhD or postdoc position abroad, not knowing FDTD simulation is a serious disadvantage. And the problem is Lumerical FDTD is always explained in the most complicated way possible. That's exactly what we are fixing here. On this channel, I am teaching Lumerical FDTD from zero, fast, practical, and with real academic logic. In this video, you will learn how to set simulation domain correctly, why long length settings slow your simulations, and how get accurate results without wasting hours. No paid course, no gatekeeping, completely free. If you are working on Plazmonik cells, nano optics, or academic applications, subscribe and stay tuned. This series can literally change your research speed. Now, after opening FDTD simulation, let's set length units. Nanometer. If you are working on big girls, for example, if you are working on waveguide or something, you can choose as much you want here. You also can change time, frequency, and other set lengths, other units from here. Another important part is resources. I am using AMD Ryzen 7 CPU and it has 16 thread. If your CPU have higher or lower, you should choose this. You should change this thread section. For example, I type Intel E5 processor and it's 12 threads. So you can come here and choose it 12. Just learn what is your CPU and do it. Okay, we are ready now. Let's add simulation region. Here is our zoom. Let's change its shape. I don't like its shape. We will work on today periodic structure. So, okay. Here you can choose the medium of simulation region. You can choose it any material. For example, if you are working on palic, chrome, gold or aluminum, you can choose it from this database. For air, you can choose it 1, or for water environment, you can choose 1.33 or 1.332. Both works, no worries. I today will work on air medium, and let's go to the geometry. Here the size I choose 708. You can choose as much you want during this. I just for fast simulations I choose this. We will work on real examples in next videos. Autonon uniform mesh accuracy is 2 nanometers. Minimum mesh step is 0.25. Yeah. Now, second most important part. If you are working on chemical synthesis particle or isolated particle like nanocubes, hexagonal structures, gold or silver cubes or something like that, you can use perfect natured layer if you are aim to calculate their absorbance or scatterings or transmittance spectra. You can use this. If you want to work on periodic structure and want to calculate reflectance or transmittance data, you should choose periodic structures. And if it's symmetric particle, you can choose antisymmetric. I will go on it later, and I will tell this later in example in next videos. Okay, now we are ready. Let's work on geometric structure. Let's make a nanodisk array, right? Rectangle. Let's name it substrate first. Okay, it will be all substrates. Now let's make it bigger than FDTD region. No worries, it's only calculate simulation only will calculate simulation region volume. so no worries about that. And the maximum 0, and this one 550. Oh. And as a material, I have to work on silicon. Oh, let's work on, where are you? Silicon. Where is the silicon? Oh, here. Okay. And all other time. Okay. Oh, what happening here? No one tell me. Okay. Now, let's add Nanodisk. As you can see, it's bigger than usual. It should start from actually over the substrate. So I will edit the position and let's make it start from 0, and I meant to make it 100 high, 100 nanometer high, and let's make it 100 nanometers region. You can make it for example elliptical by adding 200 or something, but today I want to work on Nanodisk array, and on material index I went to that gold palic. Oh, and that's it. Now we have our substrate, and it will be duplicated and became array during simulations. Okay, now we build our first structure, and it's Nanodisk array. So let's move on second video for our first simulation.